my friends, my calculus doing friends. We're looking at 4.5. Get my thing to stop shaking here. And the substitution rule, or I like to call it the unchained rule. And the reason, remember that the derivative and the integral are inverses of one another. And so I'm going to look back, I'm going to remember back when we had a function that looked like this. And we wanted to take the derivative of it. So we had to think about, oh, this is a chain rule, right? I wouldn't want to write that out 5 times and multiply that all together. And so what we would be thinking is the outside, which was 1 over 20 raised to the 5th. And then the inside, right, which is 2x to the 2nd plus 3. And then you would take the derivative of the outside. So the derivative of the outside is 5 times 1 over 20, which is 5 over 20 is 1/4, right? So this is 1/4. The same inside raised to the 4th. So you take that 5 down in front and then times the derivative of the inside. And the derivative of the inside is 4x. And then the derivative of 19 is 0. And I'm going to put that same inside in here, 2x squared plus 3. I feel like I need a sharper pencil for my writing. Happiness. And I don't know if I can just start yelling out to my family to sharpen some pencils. Boy, I'm going through pencils here. And so it used to be whiteboard markers and now it's pencils. So 1/4 times 4x is x. So this is x times 2x squared plus 3 raised to the 4th. And so there's our derivative. And then you notice that I've asked you, hey, what if I wanted to take the integral of this? And so since the derivative and the integral are inverse processes, then they're inverses of one another, then we know that the answer, if I take the integral of this, ought to be that. And so the answer ought to be 1 over 20, 2x to the 2nd plus 3 raised to the 5th, and then I wouldn't be able to know that it was plus 19, the constant, and so we put plus a constant. So it was some constant, but I wouldn't be able to figure out what constant it was. And so we know that that's the answer here because we just did this. But how could we find the integral of this if we hadn't just done that? And the answer is something called the substitution rule. Or the unchained rule, if you will, because it's going to undo that chain rule. And so they give you a theorem. And so in the theorem, they say that the substitution rule for indefinite integrals, if u equals g of x, is a differentiable function whose range is an interval I and f is continuous on I, then f at g at x times the derivative of g at x dx is equal to, now remember they let u, here's u, right, there's u, there's the derivative of u, equals the integral of f at u du. And so, so a little u substitution there, so we're substituting in for g of x, the u. And you might be thinking, well, is that what we had going there? And we did before we simplified it, right? We did have that. So this right here was, before I simplified it, was the integral of 1/4 2x to the 2nd plus 3x, 3 raised to the 4th, times 4x. And so right here was our g at x, right? And there's our derivative of g at x. So we really did, the 1/4 could go out in front. So we really did have this thing going right here, right? We had this this outer function 1/4 raised to the 4th. and then we had our inside. And so we had that situation totally going here. Then this is the substitution rule for definite integrals. So the same story here, that you have your function at some inside function times the derivative of that inside function. And you can let u equal g of x, and then this will be the same as the integral of f at u du. And then what you want to do is you want to change your bounds. Because we let u equal g of x, then our bounds will plug in, for x, we'll plug in a and b, then our bounds will be g at a and g at b. And so that's kind of the story on those. And we're going to practice this. It's actually kind of a procedure, even though we have these theorems that kind of show us. It's kind of a procedure of how to do it. And so here's the step-by-step procedure. The first step is to let u equal g of x, which is your inside function. And then what you want to do is you want to find the derivative in differential form. And so we're going to practice that again. And so I know that we did that, and you probably remember doing that at the end of chapter 3. They had us write finding the derivative in differential form, and I'm going to show you, I'm going to remind you about that. And then I like to solve for dx, and I think it's helpful when you first start anyway. And then you're going to substitute u and dx. Hopefully we end up with an integral with only u's, and if not, we're going to make it so. So after we do our substitution, if we have more than, and we're going to have some that don't have just u, then I'm going to show you how you can make it so. And it gets even trickier when you learn some more integration techniques in Math 6B. And then you're going to integrate. And if you have no bounds, then you want to make sure that you go back to x's, and don't forget to put your plus c, because you're finding the general antiderivative there, the general indefinite integral, right? If you have bounds, you have two options. You have the option of making your new bounds, making the bounds go with u, or going back to x and then using their original bounds for x. So using your old bounds. So making new bounds or making old bounds should give you the same answer no matter which one you choose. And so usually I use option 1. Okay, so we're gonna do that problem that we started off with, but this time we're not going to say, "Hey, I know the answer." We're gonna give it a try using the U substitution. So the first thing that you do is you let u, and I like to have my plan over here. So here's my plan over here. I'm going to let u equal, and my inside function is 2x squared plus 3. And then instead of writing du dx like this, du dx equals 4x like that, that's not how I want to write that. I want to write this in differential form. And so instead I want to write du equals 4x dx. So I'm going to put this dx over here. So du equals 4x dx. So times dx or just dx, whatever, however you want to write that. Then I like to solve for dx. So I like to write this as du over 4x equals dx. And so these are the things I'm going to be using to substitute. U equals 2x squared plus 3. And I am also going to substitute for dx. So where I see dx, I'm going to write du over 4x. Okay, so here's now I'm going to go substitute, right? So my integral. Now I wasn't going to replace anything for x, so I'm going to put x here. And then right here is where I was going to replace u. So this is going to be u to the 4th. And then for dx, I was going to replace that with du over 4x. So du over 4x, and times if you want to put it there. du over 4x. And did you see that I did not write 4x? I wrote something else. Okay. So now what I'm hoping is that when I reduce everything, that that all the x's will go away and I'll only have u's. And so I have my fingers crossed, right? That'll happen. And do you see that, oh, that is going to happen here, because this is x divided by x right there. So the x's reduce out. So this becomes the integral, and I'm going to just write this so that it looks nice. So this is in the denominator 4, so that's 1/4 u to the 4th du. And then I'm like, oh, I can find the derivative of that. And my choice is to hold the 1/4 steady or put it to the front. And so I just usually hold it steady. So I usually say, people say, oh, you can move that to the front. And you're totally right. You can move it to the front. And then, but to me, that's the same as just holding it steady, right? So I guess I'm kind of lazy. And so then take the antiderivative of u to the 4th, which is you add 1 and divide by the same darn thing. So this is u to the 5th over 5, and plus c. So this is 1 over 20 u to the 5th plus c. And this is a really bad joke, and I probably shouldn't even be saying it on the YouTubes, but nobody cares about you. They only care about your x. So see how I'm trying to give my answer with u in it, but nobody cares about you. They only care about x. But good news, we know what u and x are in terms of one another, so you just substitute back. So 1 over 20, and then 2x to the 2nd plus 3, that's what u was, raised to the 5th plus c. And that's the same answer that we got before. And then I asked the question, hey, how do you check your answer? Well, how you can find your answer, if you like, is you can find the derivative of this and verify that it's that, what we started with, right? And so you can certainly check your answer by finding the derivative and making sure that that's what the derivative is equal to. And so, and we've already done that, so I'm not gonna do that. But I'll put that here. Find the derivative of 1 over 20 and to verify it is x times 2x squared plus 3 raised to the 4th, right? Okay, so that's kind of our story there. Okay, we did a lovely job on that one, and we're going to try some more. And this is the U substitution, which I sometimes call the unchain rule. And I had one of my students that was in my class several years ago. He's a doctor now. He was in med school when he texted me, and he said, it started off, ha 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 ha. He sent that, and then he said, got to do an integral today and had to use the unchain rule. And so he was in his class, and it had to do with how medicine went through your body, and so they had to do. The teacher showed them that it was an integral, and then they got to do it on a program after that. But anyway, so that's what they were learning about in his pharmaceutical class. Anyway, so he told his teacher how his calculus teacher had called it, instead of the substitution, the U substitution, had called it the unchain rule, and his teacher said that he liked that better. So I'm making progress with the medical community, right? They'll soon be coming over to my way of thinking. So anyway, so I thought that was really, really exciting. Okay, so we're going to try this problem here. This is number 8 out of your textbook, and so I can't find the antiderivative of this because it's a product. And so whenever you have a product that you cannot multiply together, that's what we had here too, and I think I didn't say that. X times this is a product that I would not want to multiply together. I'm not going to say that I couldn't multiply that together, because I could write that 4 times and multiply that all out and multiply the x by it and then take the antiderivative of the pieces. So, 2 years later, right, I'd still be multiplying and probably have made a boo-boo or whatever have you. Okay, so, but this one, I can't multiply that together. And so, but I can make my plan. So my plan is to let u be the inside function. And so which one of these do you think, x squared, sine of that, sine, or x cubed is the inside function there? So this is what's being multiplied, the x squared, right? It's the product. And having a product with the sign. And so what's the inside of the sign? That's what I'm looking for my u. So that's x to the third. And then I want to find the derivative in differential form. I messed that word up. I think that's the third time I've messed it up. I think I'm working on messing it up every single time. And so du dx is 3x squared. But instead I want to write that as du equals 3x squared dx. And then I like to solve for dx, and you'll get where you don't have to do that. You'll get where you can do it without writing it like this. But this is like, the training wheels, and then pretty soon you'll be off and running. And so it's the algebra training wheels is what it is. And so let's go do what we're going to substitute in. So where we see x to the third, we're going to write u. And where we see dx, we're going to write du over 3x squared. So that's our plan. And so this is going to be the integral. Now, I wasn't going to replace anything with x to the second. So I'm going to write that down, sine. And then instead of x to the third, I'm going to write u. And then instead of dx, I'm going to write du over 3x squared. And I'm hoping, fingers crossed, right? Hoping, praying, whatever you do. And so I'm hoping that the x squared will drop out. It will cancel out. If it doesn't, then I'm going to have to make it so. We do have a few problems like that. But if it does, then I'm like hot diggity dog. And so don't worry, those problems are coming. And so x to the second reduces with x to the second, and I get the integral of sine of u du. And I'm like, well, hot dog, because I know the integral of the sine of u. That's just simply the, what is it? It's the negative cosine, right? Negative cosine of u plus c, because it didn't have bounds, right? I need to make sure that I get. So there's my integral, but again, nobody cares about you. I know it's really sad, makes me want to cry when everyone doesn't care about me, but only cares about my x, right? I mean, that's just awful. And so, but I need to replace back in there. So x to the third is what u is. So this is negative of cosine x to the third plus c. And if you wanted to check your answer and make sure that it's right, you could, by taking the derivative of this, and you'll have to use the chain rule, you can show yourself that it's equal to that up there. Oh, did I lose a 3? Because I was right now doing that with my head and saying, that didn't work. And I see where I made my mistake. And I know that some of my friends would have helped me out, right? This 3, I forgot about it. And when I was saying to you guys, check it, I was like, wait a minute, that's not going to be right. And so I missed the 1/3 right there. And so, and then the 1/3 would hold still, right? So this is 1/3 right here. And make that more clear, negative 1/3. And so this is, see how checking it is a good idea. And so I really did that on purpose so that you guys would know that you really need to make sure, right? You need to be careful. Ha ha ha! I laughed to myself. Now I can see that when I do the chain rule, that hey, I would end back up with this. I was thinking, well, where's the, when I take the derivative of x to the third, I get 3x to the second. Where's that 3 going to cancel with? Oh, there it is. Hot diggity dog. Okay, so it's always good to check, even if even if you feel like you shouldn't have to check. It's always good to check. So what do you guys think would be, I cannot find the antiderivative of that because this is a product, x times the cosine of x squared dx, and I can't multiply x times the cosine of x squared together either. So that's not an option. And you could use the substitution rule if you have a division as well. So a product or a division, you could try the substitution. So right now I think I do have a division in here too. And so what's the inside function? Because that's what I'm going to try to let u be. You got it, x squared. Then you take the derivative. So this is my plan of how I'm going to get this done. And so du equals 2x dx. And I like to put a box around that because that's what I'm going to be plugging in. And du over 2x equals dx. And I like to put a box around that because that's what I'm going to be substituting in as well, right? And then this one had bounds. And so how I'm going to handle the bounds is also part of my plan. I'm writing with this pencil that's so dull, it's like writing with a club. I almost feel like I need to prick my finger and write with blood. I think it might be better than this crazy pencil. But doesn't matter what bound you start with. So I'm going to start with my low bound, which was x equals 0. See how this is, all of this is in terms of x. So this is x equals 0 for my low bound. And then I know that my formula is u equals x squared. So u equals 0 squared. So coincidentally enough, the low bound is u equals 0. Probably not going to happen on the high bound. So we'll try it. So here's my high bound, my upper bound, whatever you want to call it. I guess I've been calling it that bound, which is x equals the square root of x, right? And u equals x squared. So u equals the square root of pi. Oh my goodness. I tried to, since I've been home, I've been allowing myself to drink more soda. And so I told myself, no soda today. And I might have to go back to it because so far I'm making boo-boos without the soda. The soda was why I was able to do math correctly. The square root of pi squared is pi, right? So this is u equals pi, and that's my upper bound for when I have u's. So when I go do all my substituting, I'm going to substitute all of this stuff in. So let's see what we have. So my bounds, my lower bound is 0, a coincidence that they're the same. My upper bound is pi. And then I have x, which I'm hoping to get rid of. Cosine, this is where I was going to do my replacing. That's u equals x squared, so cosine of u. And then dx, so I'm going to substitute in here for dx, du over 2x. And I was hoping that the x's would drop out, and you notice they do. So I really don't have x's. And then that 2, I can put it in the front of the cosine, half, or I can put it in the front of the integral, my choice. So I'm going to put it in the front of the integral this time to have some variety in my life. It doesn't matter. Whether I move it to the front of the integral or not, in my mind, I think I have. That's my deal. Because what I'm going to do with it is I'm going to ignore it and just hold it still. So the antiderivative of cosine of u is sine of u. So this is half sine of u from 0 to pi. And these were bounds for u. And so I'm not going to go back to x here. I'm just going to go with the new bounds, and I'm going to plug in for my upper bound pi. So this is half sine of pi minus half sine of 0. So the sine of pi is 0. So half of 0 is 0, and the sine of 0 is 0. And so what we're going to get here is 0, right? 0 minus 0 is 0. When your integral is 0 of something, that must mean, because remember this is area, right? It must mean that we have the same amount of area between 0 and the square root of pi above the x-axis as below the x-axis. So it must be that we have the same amount of area. And so, so that's kind of the story on that one. And so we did a lovely job on it. Now, this was option 1, to get the new bounds that are u and then go with it from there. If you wanted to do option 2, you would get the same answer, and how it would look here is that when we took our antiderivative, right, we had half sine of u. Now these things were in terms of u. These were u's, right? And so if we want to go back to x's, that was sine of x squared. Well, instead of having u's here, u's, you would have x's. And the x's were 0 to the square root of pi, right? So these are now x's because I went back to x's. These should give you the same answer. And so there's no reason to go back to x's, right? And so just so that you can see that it does give you the same answer, you get half sine of the square root of pi squared, right, minus half sine of 0 squared, and pi squared is pi, the sine of pi is 0, half times 0, you get the same answer, right? And so there's no reason to go back to x's, but this is how it would look if you did, right? You would go from here, which was in terms of u's, back to x's. And it actually makes it more complicated to go back to the x's. Do you notice that I had to do this arithmetic, the square root of pi squared, in order to go back to x's? It's actually simpler to stay with u's and just go to the end with u's. And so anyway, so that's the story there. So I told you that the U substitution would work whether you had, could work, not would work, could work whether you had a product or a division. And here's one that has a division, so that we can give it a try. Now, there are a lot of other integration techniques. And if you want to ask Andrea about them, you definitely can. And he'll tell you, because he's taking 6B, or you have another friend that's taking 6B, a whole chapter on integration techniques. And we don't do all of those integration techniques in Calc 1. And so if the U substitution doesn't work, then you would try something else. And so, but it still will be one of your tricks up your sleeve in Calc 2. And in fact, they'll say you know totally how to do the basics, light trig substitution, which we've practiced already. We've done basic ones, light trig substitution, and U substitution, the unchained rule. So they'll call it U substitution. I'm probably the only person that's calling it the unchained rule. So our plan, because I have this division and I can't integrate it, is to try the U substitution. So I'm going to let U equal the inside function, which is inside the square root 1 plus 2x. So du equals 2. Do you guys agree with me? Dx. And I was hoping that this x up here would get gobbled up. So there's actually two things about this problem. It's a division, and it doesn't look like my x is going to get gobbled up. So what the heck will I do? You know, what will I do? What will I do? I fret, right? And so don't fret. I'm going to show you what to do. So we also have to make a plan on our bounds. So this is my whole plan over here, and my low bound was x equals 0, and u equals 1 plus 2x, so u equals 1 plus 2 times 0, so u equals 1. So that's my new low bound, u equals 1. And my upper bound is x equals 4, So when I convert it into U's, I'm converting everything into U's, and I'm going to stay with U. That's my plan. Convert everything into U's and stay with U. And so 1 plus 2 times 4, right, which is 9, right? So my up bound is 9. So that's my plan with my bounds. Here's my plans with my substitutions. So let's go put it all in place. So what did we replace the 0 lower bound with? With 1. What did we place the upper bound with? 9. What did we replace the x with? Nothing yet. Uh-oh, we say. And then we get the square root of u. And then we have dx is du over 2. And this is one of those ones where I just didn't get lucky and have the x drop out. But you don't have to get lucky and have the x drop out. What you can do is you can use this, what you said u was, and you can solve this for x. So in order to solve this for x, u equals 1 plus 2x. So this is part of my plan. U minus 1 equals 2x. And so u minus 1 divided by 2 equals x. Is that okay? And so now I can substitute this in, even though it looks horrid. I can substitute this in right there for x, and then I will not have any x's. And so it's kind of like me getting to plug in again here. And so this is from 1 to 9. And this was u minus 1. I'm going to write this as half. U minus 1 over the square root of u times du over 2. And this 1/2 and this 2, people tell me all the time, hey, those cancel out. But you have to remember this is half as well. And so it's 1 over 2, right? And so really this 1/2 and that 2, really it's 1/2. It's 1/2 times 1/2. That's 1/4 is what that is. And I'm going to put that in the front. And I'm going to wish that I had more room on this problem. And with my really big writing pencils here. And so my son has taken all the good pencils, and I still love him. Oh, am I going to run out of time? Okay. 1/4, 1 to 9 of u minus 1 over the square root of u du. And I am going to run out of time, and so I'm going to do problem 48. I'm going to let you, because it's going to go into a second video, and so I'm going to let you guys see if you can finish problem 48 here. And in the next video, I'm going to start problem 48 again, just so that it starts on a good note. And so you can go forward in the video if you like, and see if you got the right answer. Okay, we'll see you in the next video. Bye-bye.